Aladdin Creations.
Okay, medical and med lab students, let's picture this. You walk into the lab, right? You're looking at a petri dish. Loads of tiny bacterial colonies.
Yeah, it can feel a bit overwhelming sometimes, like finding a specific face in a huge crowd.
Exactly. But what if you could spot some of the really important ones, the clinically significant ones, almost instantly, just by how they look?
That's the skill we're talking about today. Visual ID. But, for microbes.
And we're zoning in on one particular face you really need to know. Streptococcus pyogenes, often called Group A strep.
Right. A really common and important pathogen.
So we're doing a deep dive, pulling information straight from the key microbiology textbooks. We're focusing specifically on colony morphology, basically, what S. pyogenes looks like.
And our mission really is to boil it down for you, to extract the most critical visual clues from these reliable sources.
Think of it as a shortcut, yeah. Getting you clued up on this fundamental lab skill fast.
It's essential knowledge, really. Turning that textbook description into something you can actually, see on the bench. And just a note, this deep dive is brought to you for the Aladdin Creations YouTube channel.
Okay, let's dive in. Where are you most likely going to encounter S. pyogenes first in the lab?
Well, almost always on sheep blood agar, SBA. That's the standard medium.
Right. So what do the textbooks say it looks like on SBA? Let's start with size.
They're typically small colonies. We're talking generally about 1 to 2 millimeters across, sometimes even described as pinpoint. Tiny.
Okay, so not large or flashy. What about the shape, the texture?
Appearance-wise, usually discoid at little disc, small, and well-defined edges. One source adds it can look dry.
Dry, okay.
Yeah.
Any other texture descriptions?
Yeah, brittle and translucent were also mentioned in one text.
And color?
Typically gray, maybe turning a bit brownish if you let them incubate longer. But honestly, well, the size, shape, color, they're useful clues, right? But the real showstopper, the defining visual feature on SPA, is the hemolysis.
Ah, the breakdown of the red blood cells in the agar. Beta-hemolysis for this one.
Exactly. And it's not just any beta-hemolysis. The sources emphasize it produces a large zone, a really deep, wide zone of complete clearing around the colony.
And it looks kind of dramatic, doesn't it? Because the colony itself is so small.
Precisely. That's a key point. The zone of clearing is often way bigger than the colony that made it. Disproportionately large. That makes it really stand out on that red background.
So why does it do that? What's going on biologically speaking, according to the texts?
Well, S. pyogenes actually makes 2 types of hemolysins. Those are the enzymes doing the damage to the red cells.
Okay, 2 types.
Yeah. One works fine on oxygen, it's oxygen stable. But the other one, streptolysin O, is oxygen labile. Oxygen knocks it out.
Ah, okay. And that explains that technique you sometimes see, right? Stabbing the agar.
You got it. When you stab the loop down into the agar after streaking the surface.
You're creating an oxygen-free zone down there.
Yeah. Exactly. An anaerobic environment. And that lets the oxygen labile hemolysin go to work, which often makes the beta-hemolysis look even stronger, deeper, especially around where the stabs are.
Makes sense. So recap on SBA. Small, gray, discoid colonies, maybe dry or brittle, but the huge, disproportionate zone of beta-hemolysis is the main event.
That's the classic picture. But wait, there's another layer the sources bring up. Colony variation.
Oh, like different types of colonies on the same plate?
Yeah. You might see some colonies that look matte, kind of dull or rough, and others that look glossy or shiny.
Matte and glossy. Okay, is that just random, or does it mean something?
Now this is where it gets really interesting, clinically relevant even. It's not just cosmetic.
Okay, tell me more.
The matte colonies, they're associated with producing a lot of M protein. And M protein is a major virulent factor for S. pyogenes. It helps it evade the immune system.
So matte means more M protein, potentially more dangerous.
Generally, yes. Matte colonies are considered more virulent. The glossy ones, on the other hand, they produce less M protein and are usually less virulent.
Wow. So just by looking at the colony texture matte versus glossy, you're getting an immediate hint about its potential pathogenicity, its ability to cause nasty infections.
That's the implication, yeah.
Yeah.
Pretty powerful clue right there on the agar plate.
That's incredible. Okay, shifting gears a bit. The sources also mention how S. pyogenes grows in broth, specifically theocholical broth. That's different, right?
Right. Theo broth is used for different things, looking at oxygen requirements sometimes. And S. Pyogenes has a characteristic look in there too.
What kind of look?
You might see growth described as like a vine or streamers kind of trailing down from the top layer, or sometimes just as distinct puffed balls or clumps sitting right at the bottom of the tube.
Vine streamers or puffed balls at the bottom, what does that tell us?
It points towards its oxygen preference. It indicates a microaerophilic growth pattern.
Meaning it likes oxygen, but only a little bit. Less than what's in the air.
Exactly. Prefers reduced oxygen tension.
Okay, so let's bring this all together for, the student listening. Why is knowing all this visual detail so important?
Well, mastering these cues, the small size, the traumatic beta-hemolysis on SBA, AV spotting matte or glossy forms, seeing those streamers in Theo, it's all crucial for presumptive identification.
Presumptive meaning? Like a strong initial guess.
Precisely. It tells you, okay, this looks very much like S. Pyogenes, and that guides your next steps. It tells you which specific follow-up tests you need to do to confirm it. Things like serotyping or specific biochemical tests. Saves time, directs your workflow.
So this visual info comes straight from cornerstone texts like Jawet's, Melnick, and Edelberg's Medical Microbiology, and the textbook of Diagnostic Microbiology by Mahan and Lehman, 7th edition.
Yep, translating those expert descriptions into practical skills for you.
So the takeaway for you listening, when you're at the bench looking at those plates, really look. Try to visualize these descriptions. See that small gray colony, check for that big clear zone around it. Notice the texture, is it dull or shiny?
And maybe just pause and think about that for a second. How amazing is it that just observing the physical appearance, the morphology of a tiny bacterial colony can give you such powerful initial clues?
Yeah, not just about what it is, but potentially how virulent, how dangerous it might be.
It really makes you appreciate the amount of information that's hidden in plain sight, right there on your agar plate, just waiting for a trained eye to see it. Something to think about next time you're in the lab.